All right, so it's the first question in the Checking Yourself series of F equals MA vids. So here we go. It's my boys Calvin and Hobbes. They're riding an elevator. They're traveling up at a speed of 5 meters per second, but then slow to a stop in 2 seconds as they reach their floor. Determine the normal force acting on Calvin, who's got a mass of about 30 kilograms, even though he's just drawn in pencil, during this time. All right, so that's your challenge. So see if you can figure out that normal force acting on Calvin while the elevator is slowing to a stop. All right, so take a moment, pause the video, try it. When you're done, come on back. All right, and there's your answer. A normal force of 219 newtons. So if you got that, you're in good shape. And if not, I'm going to reveal the first hint for you. And I think you know where I'm going with this because it's called a force diagram. So one, if you haven't drawn a force diagram, then that is definitely where you made your mistakes. But in case you had a hard time drawing the force diagram, or not sure if you did it right, here is my force diagram. So let's see how that went for me. Doot. There's my force diagram. You've got your normal force pointing up, gravity's pointing down, there's Calvin, and we have an acceleration that's negative because it's traveling upwards, but you are slowing down. So you're traveling upwards, so the net force has to be against you to slow you down instead of speed you up, so therefore you have a downwards acceleration, which is going to become a negative in our equations. All right, so see if that works, see if that blocked the issues, and try again. And if not, then I'm going to come back with clue number 2. So pause the video and try and do a little better. All right, I'm assuming that if you're still with us, then you're wondering what the next step is. So the next step hides behind curtain number 2, and that would be kinematics equations. Yes, you were given a lot of information about motion, and I actually didn't tell you that, negative 0.25. I probably should have said that, but you're given an equation about motions as well, so that's where the acceleration comes from. My bad, I revealed these in the wrong order. Life goes on, because technically you can start with whatever you want. You just wouldn't have the acceleration, and then you'd have to get it from here. So you always need to do a kinematics problem and a net force equation. One of the two is going to get you acceleration. Once you get acceleration, you can punch into the other one. Since now we have acceleration, now we can do our force diagram. We can do our net force equation. So that's probably what's under here. So try and make yourself a net force equation, and hopefully that'll move you forward. And if not, I'll show you mine, and we'll see how we got there. Pause video. Or not. All right, there you go. So fundamentally, we start with the kinematics equation to solve for acceleration. Listed your givens, asked yourself what's going to get me there. Drew a force diagram as well, but did not know the initial acceleration, so had to find it from over here. Now that we know the acceleration, we can use our net force equation and build it off of our force diagram. Set equal to ma. We know the acceleration is negative 2.5. Substitute, do some math to solve. So again, recap. Whenever you're doing these types of problems that have both forces and kinematics in them, list out all the variables you know, draw a force diagram. One of those two is going to get you acceleration. Once you have acceleration, you can make the link to the other, and that's going to help you get your answer. All right? So hopefully that worked out for you, or at least it cleared some things up. If not, I've got some others. So I'll catch you on the flip side.